A supersonic fighter, landing like a helicopter. A 29,000 horsepower heart, turning it into a real-life transformer.
No runway. No second chance. Just hold her steady.
Bosh. But how do you pack stealth sensors and S-TOVL into a single frame? That's the riddle of the F-35B. Stealth doesn't mean invisible, it means buying time. Delay detection long enough, and you control the fight. Bombers slip through radar nets. Fighters flip the kill chain, see first, shoot first. Radar waves act like light. Flat panels bounce them back. Corner reflectors, two surfaces at 90 degrees, create perfect echoes. Fighter tails are perfect reflectors. Remove them like the B-2, you kill maneuverability. Keep them, you kill stealth. The F-35 had to find balance. Solution 1, serrated edges. Every hatch, every bay door, cuts the radar wave into smaller echoes like clapping hands drowned out in a stadium roar. Solution 2, the DSI bump. A simple curve of metal that replaces bulky divertors, pushes turbulent air away and bends radar waves aside. 3 wins in 1 bump, less drag, less radar. Return, less weight. Solution 3, conductivity gradient tape. Instead of one loud echo at the edge, the radar wave scatters in dozens of faint ripples, like noise-canceling headphones breaking the signal into silence. Stealth is not vanishing, it's delaying. If you show up as background noise, you get the first shot. And in air combat, first shot often means last shot.
Target locked. He never even knew we were here.
Airflow is never perfect. As air moves along the fuselage, a thin boundary layer forms slow, turbulent air hugging the skin. If that air gets sucked into the engine, performance drops. Worst blades face uneven forces, every rotation bending back and forth, a recipe for fatigue and failure.
You push the throttle, and suddenly the jet feels sluggish. That's boundary layer air choking the engine.
Traditional fighters use boundary layer diverters gaps or plates separating the intake from the fuselage. They work, but they add drag and radar cross-section, a big shiny edge for enemy radar to bounce off. The F-35's answer, the DSI bump, a sculpted bulge ahead of the intake. It creates a compression wave pushing the boundary layer away before it ever reaches the engine. One elegant curve replaces an entire plate. But that's not all. The bump also scatters incoming radar, lowering the jet's radar cross-section, and by removing complex moving parts, it cuts weight by 30%. Less drag, less radar return, less weight.
From the cockpit, it feels simple. The engine breathes clean, the throttle responds instantly, but underneath, it's that tiny bump doing the heavy lifting.
Wind tunnel tests showed the DSI could maintain pressure recovery at high angles of attack where pilots fight for their lives. And unlike older designs, it needed no moving parts, engineering elegance a bump doing 3 jobs at once. Think of it like a ship's bow cutting waves, or noise-canceling headphones cutting sound. Simple shapes solving complex chaos. The DSI bump means stealth without sacrifice. A cleaner intake protects the engine. A smoother flow saves fuel. A curved bulge makes you harder to find. 1 detail, 3 victories.
Out here, every ounce of performance matters, and if my jet breathes cleaner, flies longer, and hides better, then I live to fight another day.
That little bump in front of the F-35B's intake may look meaningless at first glance, but it stands as proof of modern stealth philosophy. 1 small detail, 3 big gains: aerodynamics, engine protection, and stealth. The Harrier could hover, but it was loud, hot, and limited. Short range, low payload, 0 stealth. The Marines needed something new, a jet that could launch from small decks, land vertically, and still be a 5th-gen stealth fighter.
On a tiny deck, no catapult, no runway. You need a jet that can rise like a helicopter, but fight like a supersonic stealth fighter.
The answer, the lift system. At its core, a shaft transfers 29,000 horsepower from the engine to a massive contra-rotating lift fan. 2 titanium blisks spinning in opposite directions, generating 85 kilonewtons of vertical thrust. Behind it, the 3-bearing swivel nozzle, 3 segmented rings, rotating in sync, bends the main exhaust from 0 to 90 degrees. On the wings, roll posts add balance. Under the LiftFan guide, vanes vector, thrust forward or back, 5 degrees ahead, 42 behind.
You feel it in the seat. 2 invisible columns holding you up, fan in the nose, jet in the tail, and and the computer's keeping it steady.
It's the closest thing we've built to a transformer. From cruise to hover, from hover to cruise, a shape-shifting machine of thrust and balance. For short takeoff, the nozzle splits thrust between lift and forward push. Add a ski jump ramp and a 27-ton fighter leaps off a deck barely 250 meters long. This isn't just engineering magic. It turns amphibious assault ships into mini carriers. The Royal Navy went further, developing SRVL shipborne rolling vertical landings, letting jets land without dumping fuel or weapons. With the lift system, small decks project 5th-gen power.
Touchdown, smooth, with bombs still on board. That's not just a landing that's preserving combat power.
Harrier once opened the age of Soviel, but the F-35B truly turns it into a 5th-gen weapon, stealth, supersonic, and vertical landing. Its 29,000 horsepower heart makes it a transformer aircraft, able to launch and land from almost any deck, turning even small ships into mini carriers. You need power for everything the F-35B does: lift, cruise sensors, and electrical systems. But power isn't free. Bigger fan, bigger airflow, different trade-offs. The engine had to be designed to prioritize what the Marines actually need: endurance thrust for STOVL and the electrical headroom for future upgrades. The Pratt & Whitney F-135 is a brute of an engine, around 191 kilonewtons of thrust from a single core, more than each engine on the F-22. But it's built with a high bypass ratio. That means a lot of air bypasses the core, producing high mass flow at lower exhaust velocity. The result: efficient cruise and massive flow for STOVL, but lower top speed, roughly Mach 1.6. That high mass flow is the lifeblood of the LiftFan. But mass flow and internal packaging aren't free. LiftFan assembly weighs roughly 1.2 tons and occupies space that could otherwise hold fuel. So the F-35B pays a penalty in internal fuel volume and therefore combat radius compared to A or C variants.
You feel it in the mission profile. Less internal fuel means more careful planning tankers, closer targets, or accepting shorter loiter.
There's another complication: electrical and thermal load. Modern sensors, EW systems, and future Block 4 capabilities require more power and cooling. Rather than swap engines for a new core, the US chose an engine core upgrade ECU for the F-135, an evolutionary path that increases electrical capacity and thermal margins to support Block 4 without replacing the whole propulsion system. The engine story is a tale of priorities. The F-35B is optimized for loiter and strike, staying longer in the target area, carrying precision weapons, and doing so from austere decks. It sacrifices outright top speed and range for endurance in contested airspace and the unique STOVL capability. With ECU and Block 4 upgrades, the platform gains the electric power and cooling to keep evolving, keeping its edge where it matters: networked, survivable strike missions.
We're not chasing speed records. We're building a jet that can get where it needs to be, see clearly, deliver precisely, and leave preferably without being seen at all.
The F-135 engine isn't just powerful, it's a design choice. Its high bypass ratio and the weight of the LiftFan give the F-35B its unique STOVL capability and efficient cruise at the cost of range and top speed. But in modern warfare, loiter plus strike plus stealth often matter more than the highest Mach number. In the densest battle space, the side that sees first wins. Air combat has always been about awareness, knowing where the enemy is before they know where you are. For the F-35B, situational awareness isn't just improved, it's revolutionary. At the heart is the AN/APG-81 AESA radar. Thousands of tiny elements, steering beams, electronically tracking multiple targets, jamming, even acting as a data link. Add to that the DAS-6 infrared eyes mounted around the airframe, giving a seamless 360-degree sphere. Every missile launch, every heat source instantly flagged. Under the nose, the EOTS electro-optical targeting system provides long-range infrared targeting and laser guidance. And binding it all together is the HMDS helmet. No more fixed heads-up display. Wherever the pilot looks, data follows night vision infrared, overlays even X-ray vision through the plane's own body.
I can actually look down through the cockpit. It's like sitting in an invisible plane.
But the real magic is what happens when you fly as a formation. Through MADL, the multifunction advanced data link, each jet shares data securely encrypted and stealthily. No radio chatter needed. Each pilot sees the same battle space picture in their helmet, updated in real time.
It feels less like flying alone, more like being a neuron in a bigger brain. I see what they see see what I see.
This is the F-35B's true edge. Not raw speed, not acrobatics, but knowledge shared, secure, immediate. A squadron of F-35s fights less like individual jets and more like a collective mind overwhelming enemies with coordination before the first shot is fired. The F-35B isn't just an airplane, it's a flying nervous system. From the APG-81 radar to the 360-degree DAS, from the X-ray HMDS helmet to the MADL HiveMind link, everything converges to turn an entire squadron into a single collective brain. In modern warfare, that means see first, shoot first, survive first. Stealth is a fragile advantage. External pylons and exposed weapons are loud to radar. So to stay invisible, modern stealth fighters carry their primary load inside. The F-35B's internal bay is the practical compromise. Carry what you need, hidden until the moment to strike. Inside the bay, you find the staples AMRAAMs for BVR engagements, AIM-9X for short-range fights, and precision-guided munitions like JDAMs and small-diameter bombs for strike missions. These weapons are released through serrated doors designed to minimize radar returns when opened.
You only open the bay when you really need to. For most of the infiltration, the jet stays clean and hard to detect. Then at the
When stealth is not required, the F-35 can carry heavy external loads over 6.8 tons on pylons to increase payload. But those pylons turn stealth to visibility radar return spike, and the aircraft becomes a much easier target. Commanders therefore choose between two modes, clean and covert, or laden and visible, depending on the mission. Some high-end weapons, like long-range missiles or next-gen standoff munitions, require software and hardware hooks in the aircraft's mission system. Delays in Block 4 upgrades have pushed back full integration of some weapons, for example, advanced European air-to-air and standoff missiles. The aircraft can carry many munitions today, but the full arsenal depends on rolling software and hardware upgrades. The upshot internal bays let the F-35B stay stealthy through ingress and strike precisely when required. External loads increase punch, but sacrifice stealth. And the platform's true long-term potency depends on continuous software and integration work, Block 4 and beyond, to accept more advanced weapons and keep the jet relevant against evolving threats.
We fly in invisible. We expose ourselves for a second to deliver the weapon, and then we vanish again. That rhythm is the F-35's combat heartbeat.
The internal weapons bay is the pragmatic heart of the F-35B, preserving stealth during ingress, enabling precision strikes when needed, and forcing tactical choices between staying hidden or going heavy but exposed. At the same time, the jet's full capability depends on ongoing software and hardware upgrades, Block 4, to integrate the newest weapons. Stealth and STOVAL are engineering marvels, but unless proven in combat, they remain theory. The F-35B's baptism of fire came in 2018 when U.S. Marine Corps jets launched from USS Essex and struck Taliban targets in Afghanistan. No catapult, no nuclear carrier. A small-deck assault ship had just projected 5th-generation power. Soon after, British F-35Bs flew from HMS Queen Elizabeth against ISIS in Iraq and Syria. These weren't just trials, they were real combat sorties delivering precision strikes and proving interoperability with U.S. and allied forces.
From the deck of a ship barely 280 meters long, you launch into a war zone and bring back the jet safely, bombs that expect.
The British pioneered SRVL shipborne rolling vertical landings, allowing jets to return with fuel and weapons intact instead of jettisoning them. At night, in rough seas, F-35Bs executed SRVLs on Queen Elizabeth's deck, another first in naval aviation. Today, the F-35B is no longer an experiment. The U.S. Marine Corps flies it as their backbone. The Royal Navy and Royal Air Force operate it from the Queen Elizabeth-class carriers. The Italian Navy fields it aboard Cavour. Japan has ordered 42 F-35Bs, modifying Izumo-class carriers to host them. Singapore has committed to a small fleet for evaluation. So this isn't just a paper plane or a test bed. The F-35B is already combat-proven, operating from decks big and small, serving as the spine of multiple forces. It transforms light carriers into true 5th-generation strike hubs and spreads U.S. and allied power across the globe.
Wherever the ship goes, we carry stealth and precision strike power with us. That's the message to any adversary watching.
From Afghanistan to the Mediterranean, from the Essex to the Queen Elizabeth, the F-35B has proven it's not just lab technology. It's the true backbone of multiple naval and air forces. Everywhere it appears, even a small deck instantly becomes a fifth-generation aircraft carrier. For all its brilliance, the F-35B is not flawless. Availability, the measure of how many jets are ready to fight, hovers around 55%. That means nearly half the fleet can't launch at any given time. Software and hardware upgrades like the crucial TR-3 and Block 4 package have faced repeated delays, pushing delivery into the 2030s. In 2021, a British F-35B crashed into the Mediterranean after a simple oversight. A protective intake cover was left on. The jet ingested it on takeoff and was lost. The pilot survived, but the incident highlighted how even small errors can turn catastrophic. Even the jet's STOVL brilliance carries a price. The vertical exhaust is so hot it can scorch a ship's flight deck. To cope, the U.S. Navy coats decks with Thermion, a ceramic aluminum spray, to resist extreme heat. Without it, repeated landings would eat through steel. Logistics have been another headache. The original maintenance system, ALIs, proved clunky and error-prone, often grounding planes needlessly. The Pentagon is phasing it into Odin, a faster, more reliable digital backbone, but the transition has been slow and costly. So here lies the paradox. The F-35B is cutting-edge, but costly, brilliant, yet brittle in logistics, revolutionary, yet dependent on constant fixes. It delivers unmatched capabilities, but only if its fleet is ready, its decks protected, and its digital lifeline stable. In the end, even fifth-generation miracles come with trade-offs.
When you strap into the jet, you trust the system has been fixed, the deck reinforced, the software updated. Because in combat, there are no excuses.
To understand the F-35B's place in history, you need to compare it to its rivals. Russia's Su-57 and China's J-20 represent alternative answers to the same challenge: how to build a fifth-generation fighter. The Su-57 focuses on super maneuverability. With thrust vectoring engines, it can pull extreme high alpha maneuvers, excelling in close-range dogfights. But its stealth is weaker engine intakes, and panel gaps reflect radar, and Russia has built fewer than 30 jets.
It can dance in the sky, but if I see it first, its agility won't matter.
China's J-20 emphasizes range and numbers. Its long fuselage houses big fuel tanks and weapon bays optimized for beyond visual range combat. Production is fast with over 200 in service, but its engines still lag. Indigenous WS-15s are not yet fully ready.
They'll field many J-20s, but questions remain about engines and sensor fusion.
So here's the balance. The Su-57 may out-twist any jet in a dogfight. The J-20 may outrange most fighters, but only the F-35B combines stealth-networked sensor fusion and STOVL flexibility. It doesn't need a giant carrier. It can deploy anywhere from small decks to forward bases, bringing fifth-generation power where rivals cannot.
That is the difference. I am not just flying a jet. I am plugging into a network. Together, we are no longer single fighters. We are a hive.
The F-35B is not just an aircraft. It is an ecosystem. A stealth airframe designed to slip through radar nets. A network of sensors fusing data into a single picture. A squadron linked together like neurons in a collective brain. And above all, a jet that can launch from small decks, hover above steel, and bring fifth-generation power to places its rivals cannot reach. From the Mediterranean to the Pacific, from small amphibious assault ships to allied carriers, the F-35B extends a new doctrine: air power no longer needs giant decks. Any ship can become a mini carrier. Any base, however short, can host stealth.
I lower the visor, I don't just see the sky. I see the battlefield stitched together by every jet, every ship, every sensor.
I am not flying alone. I am flying inside a living system.
This is the legacy of the F-35B, the convergence of stealth sensor fusion and STOVL. It is not the fastest nor the longest ranged, but it is the most flexible. It turns light carriers into strategic assets. It turns isolated Marines into a force with eyes everywhere. It turns the concept of air power into a connected ecosystem. In an age where information decides battles, the F-35B shows that superiority is not just about speed or range, it's about connection, survivability, and surprise. Its true weapon is not just stealth or thrust, but the network it creates. That is the future of air power. The F-35B, not just a plane, a flying ecosystem, a new chapter in the story of air power.